Just so some of you are aware on how this works, there is a slight delay. It appears to be about 10 to 15 seconds. So if you do ask a question in the chat, just be aware that I will get to it, but there is a slight delay, and I'll eventually get to your question. That's what you should utilize the chat for, is if you do have questions, that way I can answer them in person. And what we will be doing is our parallelograms. But just some general announcements before we do begin, which is going to be that throughout this, I'm not going to be having any graded assignments. There's going to be no weeklies. There's going to be no homework assignments. All the work that I sent, they're going to have homeworks, but they're not required for you to do during our time where the school is closed. Ryan, our stream will be the same as a class period, about 40 minutes. So around 11:40, we will stop, because after that I have to prepare for my physics stream, which I'm doing at noon. But make sure that you have these notes out, these ones that you got in class Thursday. Don't worry about that weekly that you were supposed to turn in. When we return to school, we'll just pick up with the weeklies again. We don't have to worry about it right now. But that's as far as the graded assignments go. The only reason we're doing this is we don't want to lose time, because we don't know what's going on with the Regents exam. And if we lose these 3 weeks, we definitely would have not enough time to cover everything and review. So really just absorb the information. There's plenty of practice that you can do on your own. You can always ask me stuff on Remind through this. I'm always available to help you guys out. We're going to start right from this page right here. So we're going to be doing something completely new. This is why I recommended to have some graph paper. It is not required that you have graph paper, though. As long as you see what I graph, it'll be fine. I think you can mostly see that. But we are going to do a different type of proof today. And a lot of these proofs are typically found with parallelograms only. And we're going to jump right to it. So if we remember our 5 properties, right here, of the parallelogram, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and adjacent angles are supplementary. We're going to focus on 2 of these. We're going to try to prove these in the coordinate plane. And if you remember what I said last week, you only need to prove one of these to show the other. And we're going to use one of these right here. We're typically not going to, we're going to ignore the other 3, and you'll see what I mean by that. So our 3 methods are, we could prove both pairs of opposite sides are congruent, this very top part right here, just by showing that if AB is congruent to DC and AD is congruent to BC, then we could show that it's a parallelogram. So AB and DC are right here, AD, BC right here. If we show that, we could theoretically say that it's a parallelogram. The way we would show that is if we were given the 4 coordinates, which if you see at the bottom, that's what we're going to be working towards. The way we would show that, how do we show that the lengths are equal? We would use the distance formula. That's going to be method number 1. Which we remember is this. Which the distance formula takes more time, I think. I'm not someone who uses the distance formula. You do have the option to use whichever formula you want. I'm someone who prefers method 2. So I'm going to highlight that one. I think it's a lot easier to show that opposite sides are parallel. And the way we could show that 2 lines are parallel is using the slope formula. So in this case, we could show that AB is parallel to DC, and AD is parallel to BC. And the best way to show that if they are parallel, again, we're going to use the slope formula. Remember, if the slopes are the same, that means they're parallel. So slope. Slope is also better because you can determine the slope right from a graph, which is why we will graph it in the first place. You can figure out the slope using rise over run, where distance you can't find the distance to a diagonal line. We know that. You'd either have to do Pythagorean theorem or distance formula. There's just more room for error if you're going to choose to use the lengths of the lines. I think it's going to be a lot easier to find the slope. So, slope, change in y, change in x, or y2 minus y1 over x2 minus x1. There's a third method, which we won't use, but I do want to talk about it because when we do a statement reason proof, we would more likely use this method. We won't use it in these types of proofs just because if you look, it says you can prove a parallelogram by proving one pair of sides are congruent and parallel, which means you need to show, say, AB is congruent to DC, and you would also need to show that they are parallel. The reason I don't like this method is it would require both distance and slope. But it would work. This method will be more common when we do the statement reason proofs. So now what we're going to do is we're going to take a look at number 1. It says determine whether the figure is a parallelogram using the distance formula. So we're going to do this multiple times. We'll do it at least once using distance. We'll do it once using slope. And then you can kind of determine for yourselves which one that you like. I'm also going to change it. We are going to prove it's a parallelogram rather than determine. I'm going to tell you right now, number 1 is going to be a parallelogram. And we are going to prove that. So like I said, there are 2 different types of proofs we can see in geometry. We are familiar with the statement reason one, where we put statements on the left-hand side, reasons on the other one. This is called a coordinate geometry proof. So you might want to write that up here. I like these better because I think they're easier. There's a lot less writing when it comes to these, and it's a lot more mathematics. And the mathematics behind it is typically pretty easy, because it's just distance formula or slope formula. We will have to do it a number of times, though. We do have to show that opposite sides are parallel, so that's 2 distance formulas for one pair of sides, and then another 2 for the other pair of sides. So looking at number 1, the first thing I'm going to do is I'm going to graph this. So if you do have your graph paper, go ahead and graph it. Otherwise, you can just look on with what I will graph. So I have negative 7, 4. There's A. B is 1, 2. 9, negative 8. And the last one, 1, negative 6. So I'll give everyone an opportunity to graph that if they do have graph paper. If you don't, like I said, it's fine. You can do all the math in the box right here. That's why you have so much room. I'm going to choose to use all the work in my graph paper. And for that reason, I'm going to write out my coordinates over here just so I have something to look at. So negative 7, 4. 1, 2. Is this 9, negative 8? So now that we're at this point, we are going to prove that this shape is a parallelogram. If you look at it, it looks like a pretty standard parallelogram. And the directions say we're going to use the distance formula in order to prove that. So it is going to require us to do the distance formula 4 times, 1 for each pair of sides. So I like to choose 2 that I know are going to be congruent to start off with. So I'll start off with AB and DC, and I'm just going to see what are the lengths of these lines using the distance formula. So we're going to jump right into it. We're going to do the distance between AB. So because there is so much distance formula going on, I like to write it like this, using a subscript, so it tells me I am finding the distance to AB. Remember, you're going to do 4 different distances. It's important to show who's going to be reading your work what you're taking the distance of. This is going to be the square root of, so AB, we have negative 7 minus 1. Negative 7 minus 1, close parentheses, square it, plus, then the change in y, 2 minus 4. And then just going through that, I'm going to go a little quick through the arithmetic at least. So I have 64 plus 4, which is equal to the square root of 68. I'm just going to leave it as the square root of 68. I'm not going to put it in simplest radical form. I'm not going to put it as a decimal. You could. If you do choose to do that, make sure you do it with every single number. I think it's a lot easier just to kind of do it this way. So what we found is that this line segment right here is the square root of 68. Now, if it's a parallelogram, that means DC has to be exactly the same because opposite sides are congruent in a parallelogram. So we are hoping that when we do the distance to DC, to different coordinates, we will get the square root of 68, and that's what we need to check right now. So we're going to do the distance of DC. We're going to set that equal to the square root of Now we're using points D and C. So we're going to have 9 minus 1 squared plus negative 8 minus negative 6, and then square it. That 9 minus 1 is an 8, which squares to 64. Negative 8 minus negative 6, that turns into addition, which you get negative 2 squared, so you get 4, which equals the square root of 68. Which is exactly what we wanted. We wanted to get the same length. So what I do is I make a bracket right here, and then I put a congruent symbol right there. But that's only one pair of sides that we have shown congruent. In order to prove it is a parallelogram, we do need to show both pairs of sides. One pair of sides is not good enough. So we will do now AD and BC. So here's AD, here's BC. We're going to do the distance formula 2 more times. And we should expect a higher distance with these, naturally. Just by looking at it, AD is a longer line segment than the green ones. But the yellow ones should be exactly the same length, whatever they are. So we got the distance of AD is equal to the square root. So I'm doing AD, which is this one right here. So these two coordinates right here. So we have negative 7 minus 1 squared plus now the y coordinates of 4 minus negative 6, close parentheses, and square it. So I see that double negative again right in here, so I'm going to make that into a positive. And then right here we get negative 8 squared, which is going to be positive 64. But right here we get something different. We get 10 squared, which is going to be 100. So we get 164. Just as we expected, a higher value. And we are one more away. We are now going to do the same thing and find the length to BC. And we know what that value needs to be. We just need to show the work. We know that it's going to be 164. Should I stream at less so it's easier for people to watch? I'll figure out how to change that. I'll fix that for tomorrow. Finding the distance between BC. We have 9 minus 1 plus negative 8 minus 2 squared. Set that equal to. And it looks like we get exactly the same thing. 9 minus 1 is going to be 8. 8 squared is 64. Right here we get a negative 10, which is squares into a positive 100. And we get the square root of 164. I'm going to bracket that off and put congruent. So now what we're going to do from here to finish off the proof, because remember I did change this to prove that it's a parallelogram, And you'll notice, unlike, this is very different from a regular proof. There is no statement reason. Sometimes students have the habit, they see the word prove, and they just automatically do the statement reason chart. But this is not like that. They don't give you the givens, they give you actual numbers. We do need to finish off the proof with a simple statement to basically that justifies the mathematics that we've done. And in our case, because we've done this rule, which is property number 2, we have shown that opposite sides are congruent, and that is exactly what we are going to say. So we're going to say that quadrilateral ABCD is a parallelogram since opposite sides are congruent. And that is the end of our proof. And this is one of the big things we'll be doing throughout this unit, is this process of what we call a coordinate geometry proof. We'll be seeing these with every shape that we learn from here on out, basically, in this unit at least. So when we get to the rectangles, we'll be doing these with rectangles, then we'll do them with the rhombus, then into the square. Basically, each time we do a new shape, it gets slightly more complex. But if you're able to do the parallelogram, I'm confident you'll be able to do the other shapes, as long as you know the properties of each different shape. But this is what we're going to practice. We're going to do another one, pretty much the same exact way, but we're going to do it using the slope method rather than using distance. And like I said earlier, I prefer slope over distance. We have a lot of experience using distance formula, so if you like it, by all means, go for it. But I'm going to do another one. I don't think I'm going to do number 2. I think I'm going to jump and do number 3 in our notes. So I'm just adding a new graph paper. Yeah, I'm going to jump to number... I want to make sure that number 3 is actually a parallelogram. Just give me a moment. I'm going to jump to number 4. Number 3 isn't a parallelogram, but number 4 is. So I'm going to do number 4. So I'm going to do the same thing. I'm going to graph it. Again, if you don't have a graph, just make sure you have enough room to do it. It shouldn't require as much room because we are going to use slope formula, which is a little bit shorter. And if you are graphing it, it does make the process, I think, a little bit easier because it is a lot easier to determine the slope and justify the math that way. But let's begin graphing this. We're going to do the same thing. We're going to prove it's a parallelogram. Alright, now let's graph these. 0, 8. F is 6, 10. G is 2, 0. And lastly, H is negative 4, 2. Alright, so I'm going to graph this now. 0, 8. Oh, mine went off the graph a little bit. That's all right. 2, 0. And negative 4, 2. Alright. This does not look like a parallelogram. Let's double check, make sure I've graphed all of these correctly. H is supposed to be -4 and -2. That would make a lot more sense. This looks a lot better. That right there really goes to show you why graphing this is going to be very useful. You can tell right away if it's going to be a parallelogram or not. It's immediately obvious if you've graphed one of them incorrectly. You could find exactly which point you do. You just got to double check. I just happened to write the wrong one down. But it's also why I like using the slope method, because once you have it graphed, you could just do your rise over run quite easily. Because I know when it comes to the regents, you'll see this on the regents. Very common questions on the regents as well, and they like to say the use of the graph is optional. Don't treat it as optional. Treat it as mandatory, because you graph it, you get a really clear picture of what it looks like. You know it's supposed to be a parallelogram. Make sure you get that basic parallelogram shape down, and then you can kind of go from there. But the only difference we're doing now is we're going to show that they are parallel rather than congruent. So I'm going to start off with these two line segments right here, EF and HG. So we're going to be using our y2 minus y1 over x2 minus x1 rather than using our distance formula. So we're going to jump right to that. So the slope, I'm going to use my subscripts as well. I'm going to do the slope of EF. So now we do have to do change in y over change in x. So we have 10 minus 8. So I'm using these two coordinates right here. 10 minus 8. So change in y first, then the change in x. 6 minus 0 equals 2 over 6, which reduces to 1/3. Which is great, because if you go to your graph, I think these lines are a little hard to see. But up 1, 2, your rise, run 1, 2, 3, 4, 5, 6. You can verify. I went up 2 over 6, so rise over run is 2 over 6, which will reduce to 1/3, which is another reason why I like to graph it. You can check that. If this were distance, you can't count how many units that line is, because it's going off on an angle. So it's just one of those benefits of using the slope method rather than distance. How do I know what formula to use? That's a good question. The directions right now tell us to use which formula. So in the first example, it did say use distance formula. This example, the directions do say use slope formula. In the future, you will always have the option. It is most likely going to just ask you, prove this thing is a parallelogram, in which case you can use either one. I recommend using slope. So that's a good question. Now we're going to do the other slope, which is HG, which is equal to, we have -2 minus 0, -2 minus 0 over -4 minus 2. We are hoping to get the same exact value here because we can see HG. You can do your rise over run. It goes up 2 over 6. So just make sure that your mathematics will give you exactly that. This is very easy to check. You know what you're supposed to get, so make sure that is what you get. We do. We get -2 over -6, which we have a negative over a negative. It's going to flip it to a positive. Reduces to 1/3. One of the other key differences here too is when we bracket it off. these are not, these numbers don't show they're congruent. These are slopes. Same slope, we remember, tells us that two lines are parallel when the lines are, when they have the same slope. So we use the parallel symbol instead of the congruency symbol, because that is what we are showing. And then from there, we're going to go to the other two sides. So we'll do this. Does the order matter? Does the order matter for what? In terms of which line segments we do first, how I'm writing in the numbers. What do you mean by the order in this case? How the numbers are written in the fractions. The only thing that matters is you're using the slope formula properly. Y values go on top, and that you're being consistent with when you use a y coordinate. So I'll be more mindful to explain it when I do this next slope to hopefully answer your question. So if I'm doing the slope of, I'm going to do HE right now. I'll do this one right here. So if I'm doing the slope of HE, I'm going to highlight HE. What matters is the value you choose first. You can choose either the 8 or -2. That won't matter. Since it's HE, H being 1, E being 2, I'll start with the 8, because that's the y coordinate. So I write an 8 minus, then the next number I write down does matter. That's -2. So it's 8 minus -2. Then what goes on the bottom, it does matter if I choose a -4 or a 0. Because I chose 8 first, when I wrote down, I used this coordinate first, I must write down the 0 first now when using slope, which would be 0 minus the last coordinate I haven't used is -4. So that's a case where slope does matter. We have a bunch of double negatives. They're going to flip right to a positive. So we have 8 plus 2, 0 plus 4, and we get 10 over 4, which equals, what's this, 5/2? And again, you can double check, look at your slope of that line we just did, which was HE. It should be going up 10 over 4 or up 5 over 2. We can just double check that real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3, 4. So we do get 10/4 as the slope just by looking at the graph, just by thinking about rise over run. Which now we know the slope to FG must be exactly the same. We're just going to show that work, make sure that we get it. Again, this is why I like these. There's a lot of self-correcting you can do. You know what you're supposed to get, so that's what we want to do. So we'll do this last slope, GF, which is 10 minus 0, or 0 minus 10, whichever you want to do. I'll do 10 minus 0. Since I chose the 10 first, I now must choose the 6 first on the bottom, which is now going to be 6 minus 2, which is now 10 over 4, exactly the same values as we got before, and now we can write 5/2. We can bracket this off once again, and we get that these two are parallel. I plan on doing this every school day, so not on weekends. I plan on doing this pretty much the days you would have had school. That now leads us into the last part of the proof, which is now going to be the statement. The statement is going to be slightly different than this one. There's going to be one difference, though. We didn't show opposite sides were congruent. We showed that opposite sides were parallel. That's the only difference that you're going to do. whether you choose to do distance. If you choose distance, you have to use congruency. If you use slope, like we just did right here, you're going to have to use opposite sides parallel. So it does change the symbol. Your explanation must justify the math that you did. And in our case, the math that we just did was slope, and slope shows parallel lines. That is what our statement must say. So it's going to be quadrilateral. Whoops. Quadrilateral was EFGH is a parallelogram since opposite sides are parallel. Yes, this I did make it so this should be posted after it goes live. I might try to edit down the videos so I can cut out the beginning part and just have all the important stuff in the video. Maybe post it to YouTube, but if I don't, it should still be up here for at least a week or so. So that way you can see it. Just be aware that some of my videos are going to be physics, because I am also doing this with physics at noon. So just be aware of that. What about Friday? I'm going to try to do the same time every day. For geometry, I will do both classes, 7th and 9th period, at 11 o'clock. I'm not going to jump ahead and do another example because obviously these do take a lot more time. If you want to practice some, we'll probably practice one tomorrow just to start off the stream. If you do number 2 or 3, you will find that they don't work. They actually do not form a parallelogram. Because remember, the original directions do say determine whether it is a parallelogram. So we can actually do the opposite and have a counterexample and basically show not both sides are congruent or both sides are not parallel, and that's why it's not a parallelogram, which we'll take a look at one of them tomorrow, because there are proofs where they say prove this is not this thing. But if you want to jump ahead and do that, by all means, you guys have all the stuff right here that you guys can practice this with. When it's not a parallelogram, you do show the math. Sometimes you will find one pair of sides are congruent, but then you have to show the other ones are not. When you graph it, it's very easy to determine which one's not. So technically, if you're showing it's not a parallelogram, you only need to do 2 sides if you choose the correct sides that weren't congruent or not parallel. We'll do one of them tomorrow. I'll do either number 2 or 3 to start off the stream tomorrow for sure, just so we could see one of them as well. Obviously, I'm not assigning this homework. I know you guys have it, but you guys can practice it and whatnot, and I can kind of show you the answer keys to it and so forth if you want to practice this on your own time, since you guys probably have plenty of time at home. But if you guys have any questions, please ask them. You can always just send me messages on Remind. Otherwise, I am going to end at least today's lesson here, because I am going to prepare for my physics. Just be aware that when my stream goes live again, it's not for you guys, it is for physics. If you want to learn some physics, by all means, stay on. But every time I go live, it might not be for you. I will always send out a remind saying that, I will be going live, and I will always try to do at 11. You do not need to do the homework. No, I'm not collecting homework during our time off, so I'm not going to collect homework. It's not going to be, nothing we do is going to be graded. The only thing is going to happen is when we come back to school, everything I go over in the stream, I'm not going over in class. So that's just going to be how it works. You don't have to do the homework. It's really just for supplemental practice. There wasn't going to be school on Friday? I thought we were going to have school on Friday, right? Oh, that was because of the Superintendent's Day. No, we will still do this Friday because that Superintendent's Day was moved to technically yesterday. All the teachers were in school. So I'll still do a stream to kind of make up that day because you guys didn't have school yesterday. You had no lessons yesterday. So to make up that day, I will do a stream on Friday. Correct. You're not going to have homework until we get back to school. So there will be no homework here. You won't have to hand in anything when we go back to school, except whatever weekly that you most likely have right now. But that is, you will get the homeworks in the packets that I sent home with you, but are not required to do. They are just for you to practice. As long as you're kind of tuning in, watching the stream, following along, asking questions, that is what we will be doing until hopefully we get back to school in April. All right. Thanks a lot, guys. If you guys have any questions, I'll stay on for a little bit more. But I'll be getting ready for my physics, and I'll see you guys tomorrow at 11.